In this video, we'll actually be looking at some convention that we already know, but we're going to kind of formalize it. So we're going to be talking about roots. We will see a lot of square roots when doing our analysis, but we should also kind of mention things that aren't square roots. So first, we're gonna let n be a natural number, and we should be familiar with the notation of y equals x to the power of n, right? So, for example, if we have n equals 2, then we would say that y equals x squared, which is just equal to x multiplied by itself twice. That's the idea here. And we're going to say that if we're given a value y that is non-negative, then there is exactly one, let me really emphasize this, there's exactly one value, we'll call this value x, and it's non-negative, such that y is equal to x to the power of n. And we'll see how this can be taken, or how we can get this idea way later. But for now, we'll just assume this. So what does this mean? So if we have, if you give me any value y that's non-negative, so that could be a positive number or 0, then there's one value, we'll call that x, that's also non-negative, such that this equation right here holds. So we call the solution that satisfies this equation is called the nth root. So the nth root of y. So we'll say the value satisfying this equation, y equals x to the n, is called I'll put it here, it's called the nth root of y. And again, this is convention that you're already familiar with. I'm just kind of writing it formally. And we say, we denote it x being y to the 1 over n. So basically, if you gave me, let's say you gave me a value y is 7, so for example, consider y equals 7, and some natural number will choose 3, so n is 3. So with this example, we can say that 7 is equal to some value x to the third power. And to find x, what we do is we take the nth root of y, denoted as y to the 1 over n, so 1/3. So in this case, x would be 7 to the 1/3 power. Now, when n is 2, so when n equals 2, we can also use the notation going crazy. The notation of the square root that you're all familiar with. So we'll use notation the square root of y, and that's the same thing as just y to the 1 over 2, right? So it's the same idea with y to the 1 over n. In this case, it's just a special case where n is 2. That's the only thing. So with this convention, it's always true that the square root of y is non-negative. So, and by non-negative, I really just mean it could be 0 or a positive number. And specifically, if y is positive, so if y is positive, there are two numbers whose square is y. So whose square is y. And we would denote that with positive square root of y and negative square root of y. Or we could just say plus or minus square root of y. This convention is also totally appropriate to use. Also consider the fact, so I'll write it on the right side this time. So we'll say consider, I'll scooch this over just a little bit more, then we'll look back. So consider some number r, and it's a positive rational number, so we can write it as integers m over n. And a non-negative value y, we define the following. Again, this is a property you've most likely used before. We can say that y to that power of r is the same thing as y to the power of m over n, which can be written as y to the m quantity raised to the 1 over n. So we still have that 1 over n power, right? And same thing over here, we have that 1 over n power. So we can just define it that way. And if we want to get really specific, we can say that if r is a negative rational, so if r is a negative rational, then negative r is positive, a positive rational, right? I'll just say it's positive. So we can actually say that y to the negative r is defined. So we can use it. If y is positive, we can say the following, that y to the r can also be written as 1 over y to the negative r. Again, this is stuff you've used before, right? This is practically saying I can take the reciprocal. We want to make sure that this exponent r is strictly defined, which it is, so we can use it. And finally, we can also say, if we have y and raise it to the power of 0, we just get 1. And with these conventions, it follows that if y is positive, then y to the r is defined for all rational numbers r. So if y is positive, then we can say it's defined. Yeah, so again, these are rules that you've most likely have used without thinking, really. I mean, this is just a really rigorous way to think about it. Like, you've definitely used the nth root of y, the square root of y. You've definitely seen both the positive and negative solutions for a squared number, stuff like that. So this is just me reiterating it, and it'll be good to look back at this when we actually see it come up. So the next topic will be over some quadratic equations, and we'll be formally defining some solutions.